All right, in this part we will talk about functions. All right, so first thing to know is that functions are essential components of any respectable uh, program or piece of code you're gonna find around. All right, why? Because basically functions are very powerful, they're versatile, and they are very easy to use. Okay, and you're gonna find them everywhere. So make sure by the end of this tutorial that you are comfortable with functions. You are comfortable creating functions and calling them because you are going to use them a lot later on in the different analyses that you are going to conduct. All right. Now, what is a function? A function is basically a piece of code that is executed only when called by its name. All right, so let's focus on the first portion of the definition here. Piece of code. So a function isn't anything special. It's just some statements like the ones we have written before. All right. However, that piece of code or these statements are only executed when we call that function by its name. Right. So a function by itself achieves nothing until we call that function. Now, another attribute of functions is that they usually it takes in some input or inputs, process these inputs, and then produce an output for us. All right. Now, uh, uh, some other attributes of functions are one is that they can be reused many times. So you define them once and then you call them as many times as you need in your program. So rather than writing the same piece of code over and over again to achieve the same goal, you would write a function with that piece of code and then call that function as many times as needed. All right. Another attribute is that it divides a very large program into smaller manageable tasks, which basically makes your program or code easy to read and easy to troubleshoot whenever you run into issues or errors in your program. Okay, now as we can see here, we have a simple diagram illustrating the structure of any function. So it basically receives some input, all right, but not necessarily, right? So a function might take no input at all, but it usually takes some input. So it takes the input, it processes that input using normal code statements like the one we have used, and then it produces some output for us, all right? Now, for every function, we have two main parts. We have the function definition and we have the function call, and they are totally separate from each other. All right? In the function definition part, we are basically defining the logic of the function, or we are basically defining what the function will achieve whenever it's called. Okay? Now, in the call part, we are actually using or utilizing the function that we have written in order to produce some meaningful value for us. Okay, so in the definition part, using the Python language, we have four main components. The first component is the def keyword. Def means in Python that we are about to define a function. All right. The second part is the function name. And the rules that we need to follow for function naming are the same as the rules that we use for variable naming, if you remember those. Right. So you can name whatever name you want for your function. Right. But it's always recommended that the name is representative of what the function actually achieves. So if you want to write a function that calculates the average, then it's recommended to include the average keyword in some way in your function name to indicate what it achieves. Right? Now, after the function name, we open up parentheses. We always open up a pair of parentheses. And between these parentheses, we displays the list of inputs or parameters that we expect the function to take whenever it's called. All right, and in the function definition part, these parameters or inputs are just normal variables. That's why we named them here input 1 and input 2. They can be any variables you want. All right, so it depends on the logic of your function to specify how many variables or inputs will your function take. Okay, so as we agreed, the first part is the def keyword, the second part is the function name, the third part is the parameter list between the parentheses, right? And the fourth part here is the function body, which basically consists of the statements that we want to be executed whenever we call that function. In fact, for every function definition, we have 5 parts because we still have the return part. So the fifth part of a function definition is the return part. That's where we actually produce the output that we want whenever we call that function. All right. So again, the def keyword, number 1, function name, number 2, parameter list, number 3, the function body, number 4, and then the return part. Return basically in function definition means produce or output for me. So for that we use the return keyword. After the return, we specify the value that we want to produce the moment we call the function. Okay, so that's it for the function definition. Now, a function call is where we actually call that function to again produce something meaningful, right? So let's assume that we have this program here and it consists of some statements like statement 1, 2, all the way down, right? And at a certain point in our function, we simply specify or call uh, call our function that we have defined previously. So we specify the name of the function and then open up a pair of parentheses and pass some actual input values. So again, in the function definition, we have variables that we don't know anything about yet. However, when we call the function, we actually start passing some actual values that we want to be processed. Okay? So remember, function definition and function call. All right. So let's take some examples of functions to see how they actually work in action. So here we want to simply define a function called the square, which basically receives as input one integer number, right? And then as output, it produces the square of that number. It's a very simple function. So to write this function or to define it, we start with the def keyword as we agreed, right? Second, we name our function. In this case, we want to name it a square because that's what the function eventually achieves, right? And we open up parentheses, and between the parentheses, we pass our inputs or expected inputs, which consists of one single variable. We will call it my number. Okay, you can call it whatever you want. You can call it num, number, my number, your number, any variable name you want. All right. Now here we move to the function body. Now as we can see, the function body consists of one single statement, all right, which is x, which is just a variable that we want to define here in the function body, and we set it equal to my number times my number, which is basically the square of my number, right? And in the final part here, we use the return keyword to produce the output. Now, what is the output that we want to produce by our function? X, which is basically the square of our number. All right, at this point, we are done with the function definition. Let's actually call our function to produce something, right? So in the call part here, we have some random statements that we know nothing about and we don't care about uh, at the current moment, right? Now at this point here, we created a variable called num underscore a, and we set it equal to square of 3. Now, the moment Python encounters the square word, right, it will search for function definitions with the name square, right? So the square of 3, so it will go to all the way to the definition of the square function and replace my number with the number 3. So my number is now equal to 3. Now it will go to, Python will go to the function body. X equals my number times my number. What is the value of my number? 3. 3 times 3 is 9. Now it will go to the return part, return X. What is X? 9. Now Python will go to the function call part and completely delete this part here and replace it with the returned or produced output, which is 9. All right? Okay. Uh, uh, but before that, 9 will be assigned to the variable num_a. After that, we can do whatever we want with the variable num_a, like print it out, add it to something else, or process it in any way we want, right? Next, we have another statement, which is num underscore b, a new variable, and we set it equal to square of 9. So Python again will go to the square function definition and replace the variable my number or the input with an actual number, which is 9, right? Now it will go to the function body and say x equals my number times my number, which is 9 times 9, which is 81, and then return 81. Now once the function finishes its execution, it will go ahead, delete the function call part completely, and replace it with the output produced by the function, which is 81. Right? It's as simple as that. We define the function and then we call it as many times as we want. Okay. Now, as you can see, this function definition consists of one single statement. But what if consisted of 100 statements? Then using functions would be very helpful indeed, right? Because rather than writing 100 statements so many times every time we need that piece of code, we would write that function only once and then call it as many times as we need. Now you can see the increase of efficiency that will happen in this case, right? Okay, let's take another example of another function, which is called find average. All right, find average is simply a function that takes three numbers, calculate the total, and then average average of the numbers, and then return the output for us. Okay, so again, in the function definition part, we start with the def keyword, and then we specify the name of our function. In this case, find average. Can we name it something else? Absolutely. You can name it average, avg, a, whatever you want. Again, the function name follows the same rules as variable naming. All right, now we open up a pair of parentheses here, and in between we place the input variables. They are just normal variables, okay? In this case, I use the variables grade1, comma grade2, comma grade3. We can name them g1, comma g2, comma g3. Absolutely fine. All right. Now we move to the function body. In the function body, we created a variable called total, and we set it equal to grade1 plus grade2 plus grade3 to calculate the total of the inputted values. Sorry. Next, we create a variable called average, and we set it equal to the value of total that we have calculated previously, divided by 3 to calculate the average. In the final part, or the return part, we place the return keyword followed by the variable or the value that we want to produce after the function finish its execution, which is the average, right? Now we are done with the function definition part. Now in the function call part, in some other point in our program, we have some statements here, and then we we call our function 3 times, each time with a different set of grades. Okay, in the first statement here, we created a variable which is average A. Okay, and we set it equal to the function called find average, and we pass the values 93, 86, and 90. At this point, Python will automatically go to the function definition, all right, and set grade 1 equals to 93, right? Grade 2 to 86, 93, 86, and grade 3 to 90. Next, it will go to the body and say total is equal to grade 1 plus grade 2 and plus grade 3 to calculate the total. And then average will be the total of these numbers divided by 3 and then return the average. Right? Now executing this whole function will produce the average value 89.7. Now Python again will completely delete this part and replace it with the value 89.7. Next, it will assign or it will place the value 89.7 inside the variable average A because we said average A is equal to that function call. In the same way, we created another variable average B and we set it equal to find average 95, 97, 72. In this case, grade 1 will be 95, grade 2 will be 97, grade 3 will be 72. The function will start or it will execute the statements inside the function body and then it will return the average. In this case, it's 88. So again, Python will delete the function call completely along with the parameters and replace it with the value 88. And of course, place that output inside the average B variable. The same thing for the last one, but with a different produced output, which is 88.3, and put it average C. Now we can, in some other point in our program, say for example, print average. Sorry for my handwriting, I know it's kind of awful. Average A, and that will print out the value 89.7 on the screen. Okay, it's very simple. We define the function and then we call our function. All right. A third example is a function called welcome message, which doesn't produce or return any value, but simply print out a statement to the screen. Okay, so as you can see that we've used the def keyword followed by the function name, welcome message. It can be welcome, it can be just message, we can name it whatever we want. As input, we have nothing. The function doesn't take any input, all right? And the function body consists of one single statement, which is print welcome, and that's it, all right? Now here in the function call part, we call our function, which is welcome message, and then we follow it with a pair of parentheses, right? Remember, whenever we define the function, we use parentheses. And whenever we call the function, we must follow it with parentheses, even if the parentheses are empty. We must use parentheses in function definitions and calls. Please remember that because it's important and many people make that mistake of missing them, right? So welcome message. Whenever Python see the welcome message call, it will go to the definition and start the execution of the function, which is print welcome. And the result is printed out on the screen of our computer, which is welcome. Okay, so the takeaway from this particular example here is simply that functions do not always have to take inputs, okay? It can take zero input, and that's completely fine. Another thing is that functions must not always produce or return a value at the end of their execution. It can return it's completely fine not to return anything, right? Just like this example here, we just executed the statement print welcome, and that's it. Okay. However, you can in the function call part, you can call that function uh, however many times you want, depending on your need. So creating a function in this case is still useful. All right. Okay. Now, when it comes to functions, we need to know that there are two types of functions, and this is important. So please pay attention. The first type of functions are user-defined, just like the ones we have created so far. Okay, you define them and then you call or use them. All right. Again, you define the function and you call it. So you do both tasks yourself as the programmer or the analyst. On the other hand, we have some predefined or built-in or imported functions. These functions have been defined already by some other programmer, all right? And all you need to do is just to call or use them or to tap into them, all right? So some examples in Python include, for example, the absolute function. Okay, you don't need to define that function. You just call that function by specifying its name and then by passing some input to that function. So you would say absolute, for example, -2, and the function will automatically, or the function call will be automatically replaced by the value 2, which is the absolute value of -2. Okay, the same way we can call a function called min and pass the values 2, 3, and 0. Python will replace this function call with the value of 0, which is the minimum. Now, it's important to know that these functions, right, are defined. Every function in the world must be defined somewhere, but you don't see the definition of these functions. Okay, all you need to do is just to access them or use them in your program, which basically makes creating projects or program a much easier task, right? So you just take these building blocks and use them to build your project. A third and very common function that is used everywhere is the print function, right? This is an essential function to be aware of. So you simply use the print keyword and then you open a parentheses and then you pass a string value of whatever you want to be printed on the screen. So you would say something like this, print open parentheses and say, for example, hello, right? And Python will automatically print the word hello on the screen. Okay, awesome. Now, the last part, which is very, very important, is the use of the colon and indentation in certain types of statements. All right, and they are usually used together. Why? To indicate a code block or to indicate basically which statements belong to which statements. Again, the colon in combination with the with indentation or white space are used to indicate a code block or to indicate which statements belong to which statements. Okay, so indentation is very, very important in Python. All right, so let's look at the first example here where we use a conditional, right? So when we use a conditional, specifically the if statement, we write the if keyword followed by the condition. After that, we place the colon symbol to to start indicating the body of the if statement. Now here we have these gray bars, uh, uh, which basically represent white space, right? Or nothing, okay? So we leave some spaces here to indicate that these two actions belong to this if statement. All right. In the same way here, we have the else statement. After that, we place the colon symbol, and then we leave some white space indicated by these gray bars, and we start writing down the different statements that we want them to belong to that else statement. Another type of statements that utilize this combination, which is the colon and the indentation, is the for loop, right? So after writing the header of the loop for item in my list, for example, we write down the colon symbol, we go down, we leave some white space here and here and here to indicate that these three actions or statements belong to this for loop, and therefore these actions or statements will be part of the loop and they will be executed as many times as required by the loop. All right. Similarly, we use the symbol, the colon and the indentation in function definitions, as we have seen so far, right? So you write def my function input one, and then you use the colon to indicate that you will start the definition of your function. Now we leave some white space to indicate that all of these statements here belong to the function my function. Therefore, whenever we call the function my function, all of these statements will be executed. Why? Because they belong to this function. All right. Now, inside the body of the function, for example, we have used the if statement and the for loop, right? And to indicate that these, for example, actions belong to this if statement, we yet again use the colon along with some white space here. For the else part, the same thing happened. Some white space and a colon here, right? And for the for part, we have a colon and some white space to indicate that actions 5, 6, and 7 belong to this for loop, but not anything else. All right. So the takeaway here is to always to always keep track of the amount of indentation or white space you create, because it dictates what statements belong to what statements, or the scope of your statements. Okay? All right. Now let's move on and write some actual functions here, right? So we have taken the square function. So let's define the square function using Python. All right. So first thing, the def keyword, right? Now we write the name of the function, which is square, right? Next, we open a pair of parentheses. Okay, now how many input variables or parameters are expected to be taken by this function? According to your logic, we expect only one variable, right? So let's name it num. Next, we use the colon symbol, right? Next, we go to a new line and some white space is left automatically by our editor, all right? If the editor didn't automatically make that indentation, then you need to make it manually, all right? Now, the square function, let's create a temporary variable called x, right? And set it equal to num times num. Okay, now we are not done yet. We need to return or produce that output, right? So we say return x, and we are done. Okay, let's define another function called, for example, cube, that basically cubes a number rather than squaring it. So let's say def cube, right? And then as input, the function takes only one variable, right? And now x changes. X now is equal to num times num times num. All right. After that, we say return what? X. Return X. Now, you might be asking yourself, didn't we use the variable num x and x before in the function square? Yes, we did, and that's completely fine. Why? Because the scope, all right, of these variables is just within this square definition. So this x is considered a different instance than this x right here. And num here is considered as different instance than this num right here. So that's completely fine. All right. This is called the scope of variables, by the way. If you want to study more about it, then please go ahead and use the web and the different documentations to do that. Now, we have defined both of our functions. Now let's actually use them or tap into them. All right, so let's say that we wanted to print out the square of 2, all right, or 3, for example. So we would say print, and between the parentheses of our print function, we call our function, right, which is called square. All right, now square is a function call, therefore we need to open up parentheses. Now, between the parentheses, we pass actual values or actual inputs. In this case, the value 3. All right. Now, let us run the program to see what value we will get. You can see here, value is 9, which is the square of 3. Okay. Now, why did this happen? Because Python simply took this whole function call part, right? Deleted it and replaced it with the value 9. This is what's happening in the background, right? You don't see this happening, but this is what actually is happening in the background, all right? So print of 9 is the same thing as saying print square of 3. So let's go back to the original state and print out the cube of 3. Cube of 3, right? And print the value out. You see, now it's 27. Why? Because a cube is a different function, and Python will go ahead and replace this whole thing, cube of 3, with the value of 27. Okay. Okay, now let's delete these print statements and define another function that produce the average of some grades, right? So let's call it def my avg, right? And we will have 3, or as input, the function receive 3 values or variables, right? So say a, b, and c. Again, these are called the parameters. A, B, and C are the parameters. Then we use the colon symbol, and then we leave some space to indicate the block of the function, and we say total, which is a new variable, is equal to A plus B plus C. Once done, we say average is equal to total divided by 3. At the end, we say return AVG, and we are done. Now, let's call our function and say my average, and pass 3 numbers or 3 inputs. Why? Because the function definition expects us to pass 3 numbers. So we say 2, 4, and 12. Okay. Now this by itself will not produce any output on the screen because this is just a function call. So we need to actually print out this value or put it inside some variable and then print out the variable. So we can say my average, right, is equal to this function call. Now, Python will go to the function definition, replace A with 2, B with 4, and C with 12. Add them up and then average them up, right? So then we can say print my average. Here we go. All right, let's see the result, which is 6, right? Just 2 plus 4 is 6, plus 12 is 18, by 3 is 6. So this function worked as expected. Okay, so the important point to underscore is that there is a difference between the function definition and the function call as we have seen here. All right. Now, I highly encourage you to practice defining and calling functions so that you are more comfortable with them. Open up your editor, think of some functions or tasks that you can create using functions, and start creating them. And expect yourself to get some errors or syntax errors in the beginning, and that's totally fine. This is part of the learning experience. Or the learning process, sorry. So give it some time, you will get used to them, and in fact, you will find them very enjoyable and fun to use later on. All right. Well, thank you very much for watching, and I will see you in the next tutorial. Bye bye.